Hi, this is going to be the Advanced Math new sample test for 2017-2018 for Unit 1. So I'm going to fly through a lot of this. We'll touch on it as we go. My pen's not working that great. So when you find domain range increasing, decreasing, constant, what you want to do is you want to label these points. So that's going to be -4, 3. Okay. That's going to be 1, -2. Okay, that's going to be 3, -2. And that's going to be, all right, this is going to be a point, it's going to be an arrow. Since it's the right arrow, all the way to the right, it's going to be infinity. And then since it's going down, it will be -infinity. Okay? So when you do domain range, we're looking for the smallest x value, which in all of that would be -4. Now, since that point is open, that's how we write it. Now, the biggest x value is infinity. And all infinities get that. Okay? My range. Okay? My range. My smallest y value is -infinity. My biggest y value is 3. Once again, open circle. We got that. Okay? Increasing, decreasing. Okay? What we're going to do when we do increasing, decreasing, all right, is you're going to start from the far left and work your way. So I trace, that's decreasing. So it's decreasing from -4 to 1. Then it's 1 to 3, it's horizontal, so that's going to be constant. And then 3 to infinity. So we only use the x values for these three, only the x, and it's decreasing from 3 to infinity. Now, also you can just use the open brackets for doing the notation for that. Okay? Now on this one, what you're going to have to do first is you're going to have to label your endpoints. So that's 1, 2, 3, 4, 5, 5, 3. Okay, this is -1, -1. Okay, and I have this one right here. I'm just going to make that there. That's 1, 2, 3, 1, 2, 3, 4, 5. It's 3, 5. It's pretty bad. Okay. All right, so my domain, smallest x value is -1. Biggest one is 5. Now, since these are closed-in points, notice how I write them with closed brackets. Okay? My smallest y value is also -1. That is a point. Whoops. Okay? And my biggest y value is 5. Also with the closed-in brackets. So it's basically the same domain and range, but they're closed in brackets. Now, increasing, decreasing. I just care about these. -1 to 3 is increasing, and then this falls, so 3 to 5, and this would be none. Okay? Now, with these, what you're going to have to do is this one, you're going to have to actually make a graph. Okay? So I'm going to go into the calculator, menu, graph. I'm going to type this in like I see it. X plus 2 squared minus 4, draw. Okay? Now, what I'm going to do is I'm going to plot some points here to help me make my graph. Okay? So, what I'm going to do is I'm going to find the minimum. So I go to G-solve. So I'm going to select minimum. So -2, -4. I have a point. I'm going to do G-solve root, which will give me the x-intercepts. -4, 0. And if I hit over, 0, 0. And then what I want to also check out, and I can write, actually, before I even go on past that, I can actually write some of this stuff in. -2, -4 was my minimum. I had no max. My x-intercept was x equals -4 and x equals 0. Okay? And then g-solve y-intercept 0, 0. Oops. Okay? So I'm good there. And so what my graph does is it does one of these numbers. Okay? Now, what I want to do, let's label this point. I mean, really, you can label them all if you want. But this would be a right arrow going up, so positive, positive. This is a left arrow also going up. Okay, so when I do domain, the smallest x value is -infinity, the biggest is positive infinity. Range, my smallest y value is -4. Since that is a point, it's a closed bracket, my biggest y value is infinity. Okay, increasing, decreasing. All I care about are these points. Okay, being very careful. You don't care about the increasing, decrease, these points, the x-intercepts. It's when it turns do we have to worry about that. It's very important. So from -infinity to -2, it's decreasing. And from -2 to infinity, it's going to increase. Okay? Okay. Question number 4. Very similar idea. No domain and range asked for. But I still got to make my graph. So I go into graph, exit to go back 1. -2 x to the 4th plus 2x squared. Draw. Okay, looks like that. Let's go g-solve root. Okay, I'm at -1, 0. All right, hit over. I'm at 0, 0. And if I hit over, I'm at 1, 0. I think that's it. All right, so I got x equals -1, x equals 0, x equals 1. Okay, let's find my y-intercept. G-solve y-ICPT. That's 0, 0. Okay, which I have already. All right, so what my graph looks like. Something like this. Okay, let's label our arrows. So it goes like this. Okay, so this would be -infinity, -infinity. This would be positive infinity, negative infinity. Okay, so increasing, decreasing. Okay, it's going to increase from -infinity to -1. Okay, let's zoom in to see what's going on here. Zoom in, enter. Okay, so actually, I'm sorry, I did not graph that right. I did not graph that right. This is here. This is here. This is here. So it goes through here, here, and then like that. Sometimes you have to zoom in to see it. Okay? All right, so I want to do g-solve max, that's what I didn't do. All right, -0.7, 0.5, I probably would have been able to do that. All right. Okay, so -0.7, 0.5. G-solve max, then 0.7, 0.5. Okay, G-solve minimum, 0, 0. Should have done that too. Okay, so 0.7 matters, or -0.7, 0.7 matters, 0 matters. Okay, so the increasing negative infinity to basically not -1, negative 0.7. Then from negative 0.7 to 0, it's decreasing. From 0 to 0.7, it's increasing. And from 0.7 to infinity, it's decreasing. Okay? Make sure you find the minimum maximums. I didn't do that, a very good job of that. Okay? To do these M behaviors, okay, the left and right behavior, what I recommend doing is graphing the biggest exponent. Okay? In this case, it's exponent of 3. So all you have to really do is graph that term. The other terms are really irrelevant. Okay? So what I got there is I got this. So this would be negative infinity, because it's left pointing down. This is positive pointing up. So as x approaches infinity, that's talking about this. Okay, the y would be infinity. As x approaches negative infinity, this would be negative infinity. On this one, all you gotta do is graph that term. Okay, looks like that. So this is what I got. This is negative infinity, negative, positive, negative. So as x approaches positive infinity, that's going to be negative. X approaches negative infinity, that's also negative. Okay? So basically what these refer to is they refer to the y-coordinate. Okay? All right, find the real zeros of each function. This is pretty simple. All you're going to do in your calculator is go to Menu and Equa. All right, I select Polynomial, which is F2, and the degree I have is 3 here. Okay? So what you do is you type in the number in front of x cubed, which is 2. Okay? The number in front of x squared, which is 3. The number in front of x, which is negative 8. And then the standalone number, which is 3. Let's see what we get here. All right, so we get solutions of 1. That would be 1/2, although it's not turned into a fraction of negative 3. Pretty simple. Now, on this one, the idea is this goes from x cubed, x squared, x, and number. Okay? We still have to do that here. The problem is we have an x cubed term. The problem is we have an x cubed term, which is 5. No x squared term, that would be 0. The x is negative 20, and there is no number, so that's what you'd have to type in. So 5, 0, negative 20, and 0. 2, 0, negative 2. Those would be your answers. 2, 0, negative 2. Okay? Circle whether the given functions have a positive or a negative leading coefficient. The degree, the number of turning points. Okay? So here's the easy thing to figure out first. Okay? When they're this way and this way, they're negative. When they're this, when they're this and this, it's positive. So in this case, this is going to be negative. This one would be negative. And this one looks like that, so it's positive. The next easy thing to figure out is the turning points. Okay, turning points are easy. Here, it turns once, twice. So 2 turn points. Now, to get the degree, you add 1 to the turn point. So I would be degree 3. Now, what the degree equals the real plus the imaginary. That is an I there. Okay? Now, when it slices through, this counts for 1. Okay? I get to when it touches. So if I've got a degree 3 on this, I've got 1 real. In order to get that, so I got 1 real, that means to get that to be 3, that would have to be 2 imaginary. Okay? That's my real one. Now, on this one, I only have 1 turn point. So when I go from that to that, I add 1, so that'd be degree 2. Okay? That means my total zeros, okay? My total zeros, so the degree and the total zeros are the same thing. Okay? So the degree and total zeros are 3. On this, the total degree would be 2. It does not cross the x-axis, so I have 0. In order to get the imaginary, it would have to be 2. Okay? So that's real, imaginary, this would be total. Okay? Now on this one, okay, I've got 1, 2 turn points. That means when I go to the degree, it would be 3. Okay? Now, so I've got a degree of 3. Alright? Now, this counts for, you see how it touches and goes? This counts for 2. Okay? It's called multiplicity. Okay? Counts for 2. This is 1. So I have 3 total for real. That means I'd have 0 i's. So 3, 0. Okay? 11. State the real zeros of the function and give their multiplicity. This one, anytime it's x or x squared or x cubed, that's going to be 0. Okay? So that's 0 multiplicity of 2. Alright, this, what we do is we put the opposite. So it's the opposite sign. Alright, and that doesn't have anything. This would be x equals 4. Multiplicity 3. Okay? Pretty simple. Alright? All the zeros of a polynomial are x equals 3 multiplicity of 2. Alright? X equals -1 with a leading negative coefficient. So what would the equation be? Okay? Very simple. Alright? X equals 3 as a factor would be x minus 3 multiplicity of 2 means that's squared. X equals -1 would be this. And a negative leading coefficient would mean that. So that would be my equation. Okay? Alright. Write the polynomial in factor form. Okay? So I have to look at where it crosses. 1, 2, 3, 4, 5, 6. So that's -6. That's -6 for this one. 1, 2, 3, 4, 5. This is 5. So the idea there is that's x plus 6. Okay? Since at 5 it touches and goes, it would be squared. Now, this would be positive. This would be positive. So I would just leave that as it is. Okay? All right. And that's your sample test. Okay? Just work through that, work through your quizzes, and you should be fine.